Alright, time for another DraftScience video presentation. We'll go back to wave-particle duality, photons, understanding that energy is just a reflection of forces by matter, frankly. Photons move the speed of force. They don't move the speed of light. Uh, you know, this vision of the universe, illustrated here, right? I mean, they can't draw particles to save their life. You could argue, right? I mean, the one side is supposed to be, I guess, the particle part, or maybe the other side's the particle part. Yes, it just doesn't. You can't tell. I guess they're both trying to mix waves and particles into the same image, and so both images are, that's the flag you people are waving. Like, it's a great flag, and no, it's not. It's not reality. The whole thing was, they were defining a simple model. I mean, that's the idea. At the Newton error, and a little bit beyond, and just a couple of events, took them down this other road where things just started getting messier and messier, and the messier they got, the more mess they would allow. It's, I mean, I was just listening to Feynman the other night, one of his, and he, there's little giveaway statements. He said something like, at one time we thought it was going to be as simple as, electrons and protons. Well, I think it really is that simple. There's no role for all that rest of that crap to play. They don't have any place to put it. See, they see something in their accelerator there, and they have a bunch of assumptions built into what they're looking at in the first place. So as I sort of pointed out with the linear accelerator, they changed the rules about how they measure the energy. So, I mean, halfway through the experiment, so the first half, when they're low energy, they're measuring how much charge lands on a hunk of aluminum. And then all of a sudden, because that stops working, they start measuring heat. And heat and charge are very different things, and they can be caused by different things. So, they're assuming that the electron has more energy because the electron is making things hotter, when what's probably making things hotter is you're shooting a bunch of X-rays and gamma rays at the target, and you're heating it. But anyway, I mean, it could be that simple. So they have these assumptions about what's, I would argue that based on they're not really viewing anything. They're just viewing energy levels, and then they're assuming that they can't measure the force directly when, of course, they sort of can. Directly in the sense that anytime everything they measure is a consequence of fundamentally a force. Something had to, that was the original cause. Something moving the speed of light. And they're calling that a particle, because it has a certain amount of energy. So they're just seeing gamma rays or, X-rays as particles, and they're not. So they don't have this a standard, like an electron or a proton would. Well, anyway, more further down a different road. So anyway, I have made 3 videos on photons, gravity, and energy. I should add the electromagnetic video. But anyway, just haven't gotten around to that yet. And that's about all the subjects you need, and you've gotten physics down. But anyway, done with. So those videos are, if you're going to make a comment, you probably should watch the relevant video. But anyway, so they're on the website, and they're also in a playlist called subjects. Anyway, so we're doing photon wave particle duality, and so it's just full of these wrong assumptions about fields. What is a field? They think a field is some thing that exists in the space, like an ether or something, some sort of mechanism, but they don't describe what it is or why it is or how it is, just like their gravity bent space field doesn't have any dimensionality, doesn't have any substance, it's not made of anything. So none of this physics is physical, and none of it's necessary, because again, the evidence is many steps away from the cause, the hard part. They're just, they're talking about these little abstract end results, consequences that just aren't close enough to the original. So it's sort of like the fundamental mistake of saying that we actually see photons, when which we see is electricity. We detect photons because they cause an electrical reaction. They charge something, essentially, and that's how we see them. So, your brain is processing electricity. It's not processing photons. Anyway. So, we left off somewhere around here, so we'll continue somewhere around here.
And this would later be shown to contradict experiment. Secondly, if luminous objects are continuously emitting particles of light, then Newton's theory predicted that the object should be constantly losing mass. And finally...
right, and, that's, part of what mass is measuring the forces between the little atomic bits. So they might argue that an electron has energy when an electron isn't part of any system. And I would argue, of course, it doesn't. If it's just sitting in space, it doesn't have any energy. It's done. But if it's in an atom, atoms are made in pressure. The pressure is essentially the force bits, the stuff moving the speed of light. So there's a bunch of that stuff moving the speed of light trapped inside of atoms, and that's what you're releasing, sort of directly. Now the other point is you can't move in space unless some force acts on you, if you're an electron or a proton. So anytime an electron or proton moves, it has to move because some force acted on it to move it. And the same is true to stop it. And so you're really just talking about the balance between some object's internal temperature and the external universe. So if its internal temperature is higher than the density of the force in the average amount of empty space, then it's going to emit energy, in the sense that it's creating, it's trying to expand. And the only thing that can stop it from expanding, it's pushing out. And the only thing that can stop it from pushing out is there has to be a density pushing it in. And so everything's always at an equilibrium in terms of the expansion has taken account for the fact that it has more energy in it. So that's why the sun's really big.
Newton's theory struggled to explain what happens when light passes through a narrow slit, and
so let's just understand that their theory still struggles. So let's again, because it's not right. I mean, the Young drawing is incorrect. It doesn't get a good answer. It doesn't get the complete answer. There's two patterns. That's the truth. So they keep saying double slit and two waves, and the particle splits in two. It has to split into four. It's four vectors is the math that gets the right answer. At least the math that predicts the actual pattern, which has two patterns in it. So they're the ones struggling to accurately describe the real circumstance, not the fake straw man, infantile, juvenile, immature description of the reality. So they've sold this wrong notion that there's that the opening is what's creating the wave, when it's the surfaces that's causing the effect. And it's clearer. It's just so obvious that even in the single slit, their math has two vectors in it. It doesn't have two waves in it. It has 2 points in it, the surfaces. They're causing the effect. And they're struggling to get that simple fact right.
Spreads out, a phenomenon known as diffraction. Around the same time that Newton was developing his particle theory of light, Christian Huygens, a Dutch astronomer, proposed that light was a longitudinal wave similar to sound. In much the same way that sound waves require a medium through which to travel, Huygens proposed that longitudinal light waves also require a medium to travel.
Right. These is the ether theory versus the no, it's empty space and you throw things in it. So there's two ways to look at the universe. And in some respects, it wouldn't matter if they accounted, if the etherists accounted for what their ether is, which it could be, which would be just points in space. All right, and they either have a particle there or there's no particle there. There's either substance or pressure. It's an on or an off, and the on and off can move through the space. It has a direction, and if they accounted for that, then you'd argue that that's just particle theory. So the question is just a contrast between you see the universe as a bunch of dominoes that keep knocking over and flipping back up again, and everything moves through the dominoes, or you just recognize that no, there's just a domino and you throw it from here to there and it just travels a straight line. I'd say the obvious argument against an ether is that there's no geometry for arranging it. You won't have, it's a legit checkerboard problem. The diagonal distances are longer than the horizontal and vertical distances, and there's no evidence that that happens in reality.
Through. Huygens proposed that space was filled with a transparent, massless substance called ether. According to Huygens...
Right, so they accept everything about Huygens' theory except the existence of the fundamental element, the ether. So that's the funny part. They think there's a bunch of ethers. They think there's a special ether for every single particle. Every particle has its own little magical field. I mean, I'm sorry to be... it's such a bad way to view it. To think that there's a field for every particle. I mean, why? It's just mush.
Theory. Waves travel through different materials by the propagation of wave fronts. According to Huygens, each point on the original wavefront acts as a new point source, and wavelets spread out from them.
Right, so this is the magical part where, somehow, you have to, you have to break other laws to make this possible. And the other law you're breaking is that you have to have an infinite number of these little, sources. And so, you have to believe that space is somehow infinite in the sense that the small things somehow can have infinite space in them, which doesn't, again, fails to make any logical sense. So, I mean, the principle is based on some assumptions that are really, I don't think if somebody challenged you on it, you'd have much confidence that's how it really works. So it superficially matches. Again, it creates on-off pattern, but again, that's the simplest pattern in the universe. Lots of things are going to make on-off patterns.
These wavelets then combine to form a new wavefront. Using the idea of wavefronts, not only was Huygens able to explain the reflection and refraction properties of light, he was also able to explain the diffraction or spreading out of light. Despite the success of Huygens' theory, the particle theory of light reigned supreme for over 150 years.
So again, he says these words, but it really didn't. So that's just part of the bullshit. So we can say it reigned supreme where? Where's the evidence of that supreme reigning? Because the particle theory hadn't been finished, and so it really didn't explain these things. It didn't explain diffraction and all this stuff because they hadn't figured out that a photon isn't an object. It's made of things. Like the atom isn't an object. It's made of things. Till you figure that part out, you're not going to come up with an explanation.
Is largely due to the powerful influence of Newton. After all, Newton's laws of motion and his theory of gravitation had been so successful at explaining and predicting the future motions of objects that many scientists just assumed that Newton must be correct.
Right, let's just understand, Newton didn't posit explanation. So again, there's no, to say that they're saying that Newton was correct in observing an outcome. And he didn't give you a theory for the process beyond speculating beyond saying things like, well, I'm, about gravity, well, we could be damn sure it's not magic. So he would, he would at least say, yeah, there's something. There's something transmitting the information. It doesn't just arrive. Something doesn't just know I'm supposed to go that way. It's told to go that way. So beyond that, those little obvious statements, he didn't really say much on the subject of light as a particle, because he didn't yet know what light was in terms of it wasn't clumps. He still thought it was.
When it comes to the properties of light. However, when Thomas Young conducted a series of groundbreaking experiments...
So he says it again. He said that in his little write-up about this, groundbreaking. So again, these are experiments Newton had already done. All right, so Newton had already, well tested, and that's where the whole idea of Newton's rings comes into it and everything else. So I mean, Newton had done an awful lot of light experiments. So let's not pretend that these aren't just, versions of Newton's experiments. They were phenomenon we already were well observed. So these were already things everybody knew existed, and it's just sort of pretending that all of a sudden Young showed up and showed us something new. There was nothing new here.
It's at the beginning of the 19th century. Scientists couldn't help but take notice of the explanatory power of the wave theory of light.
So again, it only explains if you can buy silly premises like, a wave is made out of an infinite number of little wavelets. You have to accept the existence of an infinity inside a confined space. Well, if you accept that, then you can call it a great explanation. But it's not a great explanation if you don't think that's likely or probable or, a great guess.
In 1801, Young presented a famous paper to the Royal Society entitled On the Theory of Light and Colours, which described the interference properties of light.
Right, and that paper contains a wrong description. Cat. Anyway, a wrong description of the reality. Okay, there's no, the two-wave theory doesn't describe the pattern. It doesn't get you the right answer. It's not the correct math. It's the surfaces that are causing the effect. So if you want to know what's going to happen with the single slit, you take two places in space, the sources, the distance between the two surfaces, and that's going to tell you what the pattern is going to be. These two surfaces, and the same is true for the double slit. It's going to be the four surfaces are going to tell you what the pattern is going to be, not two waves. Two waves won't get you the right answer. So again, he's selling this as if this is, as if Young's contribution wasn't flawed and maybe a misdirection. It was fundamentally flawed. The analysis wasn't correct, and frankly, they shouldn't keep selling this. And let's understand, Young was the first one to use apparently the word energy to describe kinetic energy versus the energy of momentum. So he's responsible for, in my opinion, two fundamental misdirections.
The first experiment was quite simple, and Young wrote, I made a small hole in a window shutter and covered it with a piece of thick paper, which I perforated with a fine needle. I brought into the sunbeam a slip of card about 1/30th of an inch in breadth and observed its shadow. Young described his observations of dark shadows caused by the destructive interference of light by writing, we may infer that homogeneous light, at certain equal distances in the direction of its motion, is possessed of opposite qualities, capable of neutralizing or destroying each other, and of extinguishing the light.
So again, there's no need to create any destroy or double light or any of that crap. That junk, garbage, because it can be understood that all you're really saying is that light has to be in phase. that you can essentially jam light just like you can jam a radio. If the frequency of the bits isn't in the right arrangement, then it can't be perceived because it doesn't contain a consistent frequency. And without a consistent frequency, it can't be red light or green light or blue light. It's some kind of other thing. It's an object we can't see because it isn't going to get picked up on the tuner, and the tuner is the electron. The electron won't behave the same if you don't hit it with, if the energy doesn't arrive on an atomic surface in the right pattern, it can't eject an electron.
Where they happen to be united. Young was referring to what we now call the principle of superposition.
All right, well, that's just, almost, too silly. I don't really think he was inferring that, okay, that the same object creates two new objects that somehow are, inverses of each other, and that they're somehow entangled, and that they go through some sort of process of being exposed, and the exposure is what makes them turn into something real and all this crap. He was just saying that they have two properties that somehow enable them to appear to cancel each other, but they're not canceled. The energy still got to the surface. The energy just isn't at the right frequency to be detected as what you sent it as. The whole point of the photon is that there's an explicit distance between pieces of energy, and that distance is essential to the speed of the electron. So the electron moves at the same, can move through the atomic substance at a specific speed. So you want to hit it and then hit it again at the right time. So if you don't have a consistent frequency, you can't keep hitting it at the right time.
Which is a fundamental property of waves. The modern analogue of Young's experiment...
No, it isn't. Waves don't superimpose. So that's just complete nonsense right there. I mean, water waves. I mean, when he says property of waves, waves don't have superposition inherently. There's physical matter that's actually in a different condition, just like Young described. It has an inverse property. So in one thing creating the transmission through the water, the highs and lows, that is the high and low pressure, is in a different order, different phase than the high and low pressure of the other wave. So it can be understood that if I have high pressure and I mix it with low pressure, I go back to average pressure. So that doesn't, that kind of cancellation certainly doesn't describe anything called a destruction. You're just taking, you can take any substance.
It involves shining a light through
a piece of paper, and you can fold it and crinkle it. There's parts that are crinkled up, parts that are crinkled down, and you know that if you add up all the crinkled up parts and the crinkled down parts, it averages out to the flat paper.
Or a narrow slit so that it spreads out or diffracts.
Alright, so again, this image, it wasn't right when, basically this is the Young's description. So again, and this single slit is what you use to make sure your light is actually straight going into the double slit. So this drawing is really screwed up for that reason alone. And we know that this single slit, as an experiment, they can't use this drawing, right? I mean, if they use that drawing, they can't make a pattern out of it. There's no interference. So they know that can't be what light does when it goes through a single slit either. That there's actually two sources. Each surface is making a wave. And each surface wave, those waves are the ones that you could draw out, like the double slit pattern, to create your interference. So I mean, this is so deceptive and so not even close to being the truth and all of that crap. I mean, this drawing is just terrible. So he's putting a single slit in front of a double slit. The fact is they actually did that back in Young's day because they had to, because they didn't have laser beams. So they had to try to make light sources produce photons that were traveling straight to do these kinds of experiments. So they had to put the light source far away and they had to do something to filter out the light going in different directions. And that's what the little slit before the double slit experiment did. So I mean, this is just terrible. So anyway, the double slit is not a pink and a green wave. There is not a single wave coming out of that opening and then a single wave coming out of this opening. That math doesn't get the right answer. It doesn't describe the actual pattern. The bars are the wrong size and in the wrong locations. It won't work because that math would be generalized to a point in the middle of the two surfaces. Now they just use the distance of this middle impediment when they do their cheap version. And so you can understand that they've completely ignored the double pattern because they don't have the other distance in the math. They just have the one distance. So they're just doing the the large pattern, and they're ignoring the small pattern. Okay. Continuing. But to understand, this double slit would have 4 waves. 4 on each surface. And that's the math that gets the right answer. Those distances, the distance between the two closest surfaces and the two furthest away surfaces, those two distances gets the right answer.
The diffracted light is then used to illuminate 2 small parallel slits. Further diffraction at each...
So again, this is just such a misrepresentation. So this is clearly it's an illusion that these slits are much further apart than the single slit. So I mean, obviously you can't draw this stuff. But again, the point of doing the single slit first is to straighten the rays, not to create a diffraction. Diffraction's not going to help you. The part you're after is that some of the photons will actually go straight through the little opening and won't be diffracted and will go straight to the target. It's the straight moving light you're after, not the diffracted light. The straight light is the one that's going to go into the double slit because the distance is going to be very great.
Of these slits causes 2 sets of overlapping waves which interfere with each other according to the principle of superposition.
So it doesn't happen, it's not accurate, it doesn't get the right answer, and yet, you know, these videos will get hundreds of thousands or millions of views, you know, and it's junk science. It's absolute garbage. It's rubbish. It's trash. It's pseudo physics. It's crap.
Producing an interference pattern which can be projected onto a wall or screen. The interference pattern consists of a distinctive series of light and dark fringes.
Right, and there's really no point in showing it in this form because that's not what the photon experiment will give you. It gives you, you know, there'll be another set of bars created out here, and there's no point in doing it unless you do it with the monochromatic light to make it, you know, more rational. Because yes, the red, the green, and the blue light will, the higher the frequency, the more frequencies you can fit. That means the smaller the bars will be. So there's more blue bars than there are red bars. If you take this out further and further and you start counting them, there's more blue ones per an amount of space than there will be red ones.
The dark regions represent areas where the light intensity is close to 0. How can this pattern be explained? Young assumed that light was a wave which propagated through space in much the same way that a water wave moves across the surface of water.
No, I just say it again, it doesn't work. It doesn't get the right answer. So 2 waves going through the opening has nothing to do with getting the right answer. It's the distances between the sources that's defining the vectors and deciding where you're in phase when you have your final product hit the surface. It's just about phase and being in phase and being out of phase. The photons that have their phase broken are invisible. The ones where the phase is recreated are maintained as consistent. Those are the ones you see. But the same energy hits all the locations. The same amount of, if they could measure the heat hitting the surface, the total energy hitting the surface, all the surface is being hit by exactly the same amount of energy. It's just that some of it can't be seen as light.
The distance between adjacent crests is referred to as the wavelength of the wave, and the height of the wave above the equilibrium position is referred to as the wave amplitude. According to Young, the amplitude of a light wave determines the brightness of the light. The larger the...
Which doesn't make any sense for a single photon. A single photon doesn't have a brightness. So all of that crap goes nowhere. Doesn't make any sense that you could have an amplitude to the single photon. You can only have an amplitude of the number of photons you send. So wave theory crashes for that reason alone. There's no logic for defining amplitude, because the photon would have to be, all the photons would have to be turned into one big wave. So, I mean, do you really think that's what's going through is one big giant wave? There's not a bunch of discrete little waves going through the single or double slit. There's little packets, right? So the whole wave packet thing is destroyed by this kind of notion that the wave represents an amplitude, because the wave can't represent the amplitude.
The amplitude, the brighter the light. Young was able to use this wave picture to explain the light and dark fringes. When the
inaccurately, so this, I guess, just keep saying it over and over and over again. If they do this math with any precision, actually do the experiment, do the measurements, they'll find that it won't work. I mean, they still haven't acknowledged that when they do their math, they're doing a distance to the target. That distance is essentially a radius. So the math is actually telling them the pattern on a curved line of the same radius from the slits. So you can't view it mathematically on a flat screen. The mathematics is not describing what you get on a flat screen. The mathematics is describing what you get on a curved arc.
Light falls upon the two narrow slits. It diffracts at each slit and spreads out.
Alright, so again, that won't get you the right answer. And if he did this with a single slit, there'd only be one wave and there'd be no interference. So the only way you can get interference is, the interference pattern, is you have to have two sources. And the two sources are the distance between the two surfaces, because those are the two places the light is coming from. The light is getting scattered on the surfaces, the little bits of what we call a photon. And there's places where you'll have them back in phase and places where they won't be in phase. Nothing will interfere. Nothing will hit each other. No, there won't be anything other than in phase and out of phase. And if they're out of phase, there's no photon. You can't see it. The energy hit, but it's the bullets are not hitting at the right sequence. And the places where the bullets hit the right sequence, there's the right amount of time, the period between them, then you have a photon again.
The two sets of diffracting waves overlap one another in space. If two waves meet at a point in space, then the net displacement of these two waves will be equal to the sum of the individual displacements at that point. In other words, if a peak of a wave from the first slit encounters a peak of a wave from the second slit, then these two waves will add together,
Right, so there won't be any break in the frequency. So you haven't messed up your frequency. So if you keep them in phase, then you can receive the energy as a frequency. You can tune in the radio station. But if they're out of phase, you can't. And that's the difference. If they're out of phase, your tuner can't see the underlying frequency. So I can't really make it out of this, but there's no combining and subtracting. There's just in phase and out of phase. In phase means you can receive a signal. Out of phase means you can't. If I put two 50 hertz signals on top of each other out of phase, it'll look like 100 hertz. Because, the phases will be exactly out of phase and you'll end up with twice as many bumps. But if they're in phase, then it's back to 50 again.
forcing one another to produce a large amplitude peak, corresponding to a bright fringe. We see from the diagram that this will occur along each of the following lines.
So he's just saying, where are they in phase? And again, he's pushing the lines to a flat surface, which isn't the math. So again, it should be on a curved surface, and there's clearly, you can just look at it and say, oh, there's going to be a certain number of places where it's in phase and out of phase. There'll be a certain number of these lines. All right, and that line is an exact representation of how many wavelengths fit in the distance between the two surfaces. So the distance between the surfaces has in it exactly that component. So it'll tell you, if you just measure the distance and divide by the wavelength, you'll know exactly how many of these lines to draw. And because the lines are all going to be equidistant from each other, see, the curved line will show you that each one of these lines is the same distance from the other lines. They're all the same size. But if you do this expanded out thing to a flat surface, this one, look, this looks way bigger than this one. It's not any bigger. It's exactly the same size. The distance between this point that's in phase and this point that's in phase is exactly the same mathematically. So they're all going to be the same size. They're all going to be spread the same amount. And so it's a finite pattern. It has a finite number of constituents in it, and they imply infinities by having it go out to this flat surface. They're implying that it's an infinite pattern. It's not infinite at all.
If, on the other hand, a peak encounters a trough, then these two waves could cancel, resulting in a net displacement of 0, which would correspond to no light or a dark fringe, as Young had observed. We see from the
So again, the dark fringe just means that it's out of phase and it won't eject an electron, and it won't create charge, and won't create electricity, and it won't create a reflection of a photon either, because the photon isn't in the right sequence. It's lost its consistency, and without its consistency, it can't cause the photoelectric effect.
Diagram, that dark cancellation of the two sets of waves will occur along the following lines. So we see that the pattern of light and dark fringes can be explained using the wave theory of light. And
it can only be used if you don't mind getting wrong answers. So that drawing doesn't have the the right sizes. So if he did it with the single slit, he wouldn't be able to explain the giant thing in the center. The center bar is going to be much bigger, 2 plus the size of all the other fringes. That math won't explain it. And again, in this case of the double slit, he's totally ignoring what we know about the double slit pattern, which is that there's two patterns. There's an envelope pattern and the underlying pattern. And the only way you destroy that is by either having the slits smaller than the wavelength of light, or having the impediment in the middle smaller than a wavelength of light, because then you've destroyed the difference in the distance. You can't create more than one bar then. You make the slits in smaller than the wavelength, then how many wavelengths do you have inside when you do the division? When you divide the wavelength into the size of the slit, if you come up with the answer 1, well, that means you have one big bar. So they're just annihilating the envelope pattern to pretend this math works when it clearly doesn't work. I mean, when you have to go to this kind of chicanery, when you have to mold your evidence, so carefully, again, that provision, he might mention it here, but I don't know, that, the slit width has to be smaller than the wavelength of light. Why? Why would you do that? Why would you do the experiment that way? You won't get a pattern you can see really well. You get a much better pattern if you have it like 50, or 100 wavelengths. You'll get a great pattern. Really visible, really clear. Why would I do it this stupid way? Oh, that's right, because their math doesn't work unless you break the experiment, essentially. You have to break it. You have to put it into a tiny pigeonhole of tiny circumstances, because only in one circumstance, like a broken clock, only one time a day is it right, or twice a day. So that's what they're stuck with. So they're giving you the broken clock example. They're pretending that reality is the broken clock example and that their math works for all examples because it works on this broken clock example. Well, the broken clock example, yeah, it works for that, but that's because you destroyed all the nuance of the pattern. It's really not the average pattern. It's not it's not a fair representation of the pattern. It's a complete, it's a lie. It's what it is. I'm just saying, for them to go through all this crap to make it work, they had to know, why am I having to do this? Why do I have to narrow the variables, narrow the circumstance? Why do I have to do all this confining to make it work? Why do I have to break the clock? And they should have known, oh, because it doesn't work. That's why. It's not the right answer. The theory isn't correct.
The principle of superposition. To understand the double slit interference pattern a bit more quantitatively, we need to consider the paths of the two sets of waves travelling from the...
So again, he keeps saying it, right? He just keeps doing it. They keep saying two sets of waves. No, there has to be four to get the real double slit pattern. So again, this is just... I mean, I don't know what he doesn't know that there's other math that uses four sources that gets explicitly more correct answers. He's not aware of that. I think he is.
Slits to the screen. Each slit is a different distance from a given point on the screen. Thus, different numbers of wavelengths fit into each path. If the
So this is, in my opinion, a terrible way to draw it. The way to draw it is just to draw the fact that you're drawing a straight line from 2 points, and you could just put notches on the straight line to represent a wavelength of distance. And you could just notice where the two notches line up and where the notches don't. So if I make one a little too long, then the notches aren't going to line up, and then they'll line up again, then they won't line up, then they'll line up again, then they won't line up. And I'll be creating this on-off pattern. And clearly I can't do it on a flat surface. A flat surface won't get me the right answer because the path lengths won't be correct. They won't be obeying your math. Your math is describing points on an arc. They're not describing points on a flat surface.
difference in path length between the two paths to a point on the screen is equal to a whole number of wavelengths, then the waves will arrive at the screen in phase, or crest to crest, producing a bright fringe. If, however, the paths differ in length by half a wavelength, then the waves will arrive at the screen out of phase, or...
So just understand that it's obviously not just about being in phase and being 100% in phase, like perfectly in phase, or perfectly out of phase. Clearly the fringes are, the light fringes are larger than the dark fringes, so you could argue, just visually, that the precise midpoints aren't really deciding. It can be off a little bit and still create a visible photon. So the frequency, the period between each element doesn't have to be precisely correct. It just has to be in a range. And the range has more latitude towards making a photon than breaking the photon. So more photons are made, and that's why the light fringes are larger, and fewer photons are completely destroyed, or unseeable.
peak to trough, causing destructive interference, which will result in a dark fringe. These observations of superposition and wave interference supported the earlier work of Huygens and could not be explained by Newton's particle theory of light.
So again, obviously Newton couldn't explain it because Newton didn't have, he didn't know even what atoms completely, didn't understand electrons, protons, all this kind of stuff. So again, who would have the expectation that Newton would explain all this stuff? Would be ridiculous. And nor did Huygens explain everything. So again, Huygens relied on infinities. So they're both flawed theories in the sense they both have to be in a world that we know is very different now. So we should just make the distinction that when they say this crap, they're not saying that no particle theory could explain, because they haven't tried all the particle theories, quite obviously. So they're just forcing all theory to be with the person who first said it and said it doesn't advance from that point. And that's a huge, giant failure here. And again, let's just understand this Young drawing, this Huygens view of how waves are propagated, are created, isn't accurate, because we know light's not doing that, because it's not the two-source experiment, it's the four-source experiment. It's not about the two slits, it's about the four surfaces. Shit.
Signalling a major blow to the particle picture of light, and a major success for the wave theory. But the story
So again, there's no success here except for if we distort reality and pervert it. So, I mean, years ago, I didn't know all this crap, so I couldn't have caught them in all this crap. But they always kept saying this thing. Well, if the slit width is smaller than the wavelength of the light, why would I make the slit width smaller than the wavelength of the light? That doesn't make any sense. Why would I use infinitesimally small slits? Why would I do that? I can get the pattern without that, so why would I do that? Why would I make it harder to do the experiment when I can make it easy to do it? Oh, that's right, because their math doesn't work unless you do that. Unless you break the clock, you have to make the real clock, you have to break it at their time, at the time of their broken clock. That's what they're forcing you to do, is take a working clock and break it so it fits their broken clock. But that's the only way their theory works.
didn't end here. Towards the end of the 18th century, physicists had begun to realise that there was a deep connection between electrical and magnetic phenomena. The first documented account of this link occurred in 1820 during a lecture by the physicist Hans Ørsted. For one of the demonstrations in the lecture, Ørsted had a wire connected to a battery. During the lecture, he noticed that a compass needle near the wire spontaneously moved away from magnetic north when the battery was connected.
I don't know why they would use the word spontaneously. I mean, why would they? Why do you need that word? It moved. Okay, why would you say spontaneously?
Or disconnected from the wire. Although Ørsted did not realise it at the time, this demonstration showed that there was a deep connection between the changing electric current caused by the connection and disconnection of the circuit and the creation of a magnetic field surrounding the wire.
Right, so magnetism has a signature. So just like photons have a signature, that is, each wavelength change, each change in the period between the frequency of the composite object, the hitting of the energy, the quanta. Also, there appears to be something about the effect of magnetism that creates a pattern that can be read by compass needles. It's a pattern again, but that's all it is. It's the same force. Same force as gravity, same force as light. All the stuff moving the speed of light is all the same stuff, and all you're saying is what's the pattern? So there's a pattern for magnetism. There's the reflection. What reflects off a magnetic surface looks different than what reflects off a non-magnetic surface. So if I hit something with I could hit it with a white light, and I get a reflection of red and blue and green, right? I can separate the frequencies. Well, the same thing's happening with magnetism. It's separating something distinctive about the force, the little bits, and it's separating them, segregating them. So now they can have an effect on something that can detect that segregation, the difference between them.
However, the nature of the relationship between the two was not clear. In 1864, James Clerk Maxwell published a paper in which he gave a mathematical description of the relationship between electric and magnetic fields. Not only did his equations account for all observed electric and magnetic phenomena, his equations also...
It's not true, so that's an exaggeration. He didn't account for all phenomena. Come on, that's just way stretching. So the idea of making light into electromagnetic fields, but I'm just saying that obviously the relationship is that it's all the same force moving the speed of light. That's what everybody should have realized from Maxwell. It was that Maxwell didn't derive the speed of light. he derived the speed of force, and that the realization should be that light is a force, like magnetism. You can see it. There's a quality to what's happening that is detectable, the difference. So magnet on, magnet off, North Pole, South Pole, we can detect the difference. We can't do it with our eyes, but we can do it with some other device that can see the difference, and that's all there is. And that's the only relationship that you should have paid some attention to. Forces can affect electrons and protons in opposite manners, and that's the part that should be focused on.
Predicted that waves of oscillating electric and magnetic fields should exist with a speed that could be calculated using the measured constants of the theory.
So these weren't measured constants, so that's another lie. So that's just crap. There's no measured constants here. I mean, the permeability and permutivity of space weren't measured constants. So they were already derived from the speed of events in electrical events. So they already knew the speed of light because they already knew the speed of electricity and magnetism. And that gave them the capacity to derive the speed of light. But there was no measured quantity. No one ever measured the permutivity of empty space.
Using the measured values of these constants from experiments, Maxwell obtained a value of 300 million meters per second. Comparing this value with the recently measured values for the speed of light, Maxwell wrote, "The agreement of the results seems to show that light and magnetism are affections of the same substance."
And there you go. So why are we calling it the speed of light when we really should be calling it the speed of force? Because you just acknowledged it's the same as the speeds of the other things we call a force. So right there we should have just said, yeah, okay, so why are we saying speed of light? If they're all the same thing, affections of each other, whatever, why would we call them, why would we use one of them to define what it is when, it's like Superman versus superhero, right? The Superman is a superhero. You don't travel the speed of Superman, you travel the speed of superhero.
And that light is an electromagnetic disturbance propagated through the field according to electromagnetic laws. Maxwell quickly realized that if the speed of light was constant, then there must exist a whole spectrum of wavelengths and frequencies of these newly discovered electromagnetic waves. And by the end of the 19th century, both radio waves and X-rays had been discovered.
Right, so that was sort of took Hertz 10 years to do it, well, 7. Okay, so Maxwell declared it probably exists, and then Hertz took him 7 years to find radio waves. But again, the idea that there exist these patterns in a field of energy doesn't in any way demonstrate that anything's doing this electric field, magnetic field nonsense.
At the turn of the 20th century, it appeared that physics was divided in two. Firstly, you had the physics of matter, based on the concept of atoms, which was supposed to obey Newton's classical laws of mechanics. And secondly, you had light.
Well, it couldn't obey Newton's classical mechanics because the matter was made out of charge. Okay, so let's just understand Newton had no idea there were two charges fundamental to how matter existed, and that the two charges behaved oppositely to the same conditions.
Radiation more generally, which in large part due to the work of Young and Maxwell, was based on the concept of wave propagation in a hypothetical medium known as the ether. However, these two realms of physics could not remain alien to each other forever. If physicists wished to understand the radiation properties of luminous material objects comprised of atoms, then a fusion was required capable of explaining the energy exchanges between...
So luminous material objects, so again, it's the force is always moving the speed of light. So the stuff moving the speed of light travels through the universe, and you can't destroy it, so it's got to be reflecting off everything. So even when it's absorbed, it's coming back out again.
between matter and radiation, and that is where the next set of difficulties arose. In attempting to explain the radiation properties of hot objects, John Rayleigh and James Jeans had combined the newly discovered electromagnetic theory.
So this part, I don't know. I don't even know why he's putting this into wave-particle duality. Because this effect just has to do with the fact that, if you thought about it and you said the universe has a certain average temperature, it would be hard for the universe to create a higher temperature, but it would be easy for the universe to create a lower temperature. That would be the argument, is that a low frequency is easy to create. The higher frequencies are the ones that are harder and harder to create. So there was no rational expectation that there'd be some linear line and you draw this line and say, okay, there's going to be just as much of every kind of frequency in the universe. So the obvious point would be is that you'd recognize that it's not going to be that kind of line. So this is the kind of line you have, right? You have a line describing a circumstance where there's a certain point you get to where it gets harder and harder and harder to make something going faster or faster, that is vibrating at a quicker rate. So the higher vibrations can't be made inside the atoms of a certain size. They can't make a higher frequency because the size of the atom says, I can't do that. I can't bounce that ball in the space that's provided. Again, maybe that's a way of saying it. There's not enough space to reflect at that speed. There's too much space. You can't cover the distance and reflect in the amount of distance you have to cover. So the point is I guess it's sort of like saying that two electrons can't get really, really close to each other because it would be a tremendous amount of energy. And so they'll never create a frequency based on that distance between them because they'll never get to those distances because those distances are so extremely high pressure. There has to be a tremendous amount of pressure on the outside to push two electrons that close together. So there'll never be anything bouncing between two electrons at that small amount of distance, that small wavelength. So again, I'm just saying there was no rational expectation that it was just as easy to make a gigahertz frequency as it was to make a hertz frequency. That was a silly expectation. So there was no catastrophe. There was just learning that, atoms can only produce a certain frequency and that's it. They can't go any higher. And it depends on the atomic substance, right? So they have to make X-rays with certain materials. You want to make an X-ray, you can't use anything. You can't just shoot electricity through a piece of chalk and say, there, I'm making X-rays. Because X-rays require a certain atom structure to be able to create that, so a certain closeness between electrons probably, to be able to create this small frequency, the high frequency. So the high frequencies have to be created by atoms that are capable of vibrating at those high speeds, or electrons more specifically. Electrons in atoms that will allow them to vibrate at those high speeds, those high vibration rates. Probably a more precise way to say it. I may have to take a little pause and do a little bit more, see if we get halfway. Yeah. Yeah, I'm back. So Rayleigh is sort of famous for Rayleigh scattering. So this is sort of where he's going to start arguing about quanta and particles and pointing out the particle side of the duality problem. Because the idea is that the what's getting you have to have particles. Scatter only works for particles, doesn't work for waves. So photons start looking like they're made out of some pieces, and that the pieces are dependent on I can't even say they've never acknowledged polarization, and polarization is the huge part of a photon. It just says to you overtly, photons, whatever they are traveling through space, through a very large amount of space, and that single electrons aren't making a photon. They're only making a piece of a photon.
Theory with the well-established statistical laws of thermodynamics. However, to their alarm, they found that their theory predicted that hot objects should be emitting an infinite amount of energy at high frequency. So serious was the problem that it was dubbed the ultraviolet catastrophe.
So again, there was no catastrophe unless you had an expectation that was kind of ridiculous. Yeah, that frequency was easy. It didn't matter. High frequency, low frequency, equally easy to create. The universe makes one just as easy as it makes the other, which just isn't true.
The solution to the problem was provided by Max Planck, who, in an act of desperation, realised that instead of assuming, in common with the classical wave theory, that energy is transferred continuously, he assumed that it was transferred discretely in chunks or quanta, with the energy of each quantum being proportional to the frequency f of radiation.
So this was helpful and, in my opinion, a complete disaster, in the sense that it's helpful to recognize that there's the elemental, fundamental energy is in clumps. But it was really bad to associate energy and frequency as if frequency innately made something more energetic when it's not innate. It's a consequence of the fact only that frequency means you can fit more of the quanta in a smaller area. And so, of course, it seems like it's more energetic, but the ultraviolet light isn't more energetic than the infrared. It just has more bits in it. It has more bullets per square inch. And if you're going to get hit by more bullets per square inch, well then obviously it's going to seem like you got hit by more. It's more. But it's not more in its elemental form. The elements are still the same little quanta.
In this way, Planck was able to tame the infinities of the ultraviolet catastrophe and account for the radiation properties of hot objects. However, the success of Planck's ideas entailed serious consequences. If energy is quantized, then surely light, which carries energy, should be quantized too. Perhaps Newton was right all.
So light doesn't carry energy, it is energy. It's a force. It's made out of little discrete bits of momentum. And if the momentum hits at the right frequency, it'll produce an effect on an atom. So if you want to knock an electron out of an atom, the key to doing it are atoms, a collection of atoms. The key to doing it is to hit it the right way, and just as important as resonant frequency. You hit something and it vibrates at a frequency that is consistent with the reflections being in phase, okay, with the energy you put in. So the energy you're putting in is reflecting at the same phase as that other energy, and therefore it's not destroying. Okay, it's not you don't have two pieces you don't have a piece of something going both this way and therefore not going anywhere. You store energy at those frequencies. So that's the important part, is that the atom's only going to release the electron if you add energy constructively, in the sense that you push it, and then, like a pendulum swinging, you wait for it to start going in the same direction again, then push it again. If you push it when it's going in the opposite direction, you won't get your electron up to a faster speed. You have to keep pushing it while it's going the same way as the energy's going.
Along, and light is comprised of particles after all. In 1905, the existence of a granular structure of light and of other radiations was confirmed by Einstein's explanation of the photoelectric effect. So what is the photoelectric effect? If a beam of light...
So this is another subject completely broken. Now this is, it's obviously what he just said is really good for me, in the sense that he's just acknowledging that Einstein proved it's particles. But he really didn't. Okay, because the fact is you're detecting the light with a clump detector. You can only detect light as clumps of electricity. You can't detect it as anything else. So you're really not detecting the source of the light. You're not detecting its fundament. You're not detecting what it's made out of. You're just detecting the fact that a certain amount of this force stuff triggers an electron event. So we're really just talking about electrons come in clumps. Of course, we already know that. We haven't proven that photons do. So I think it's just not very good reasoning. Even though it's on my side, I'm just pointing out this piece of evidence is badly described as the other pieces of evidence. They just don't do it very well.
Above a certain threshold frequency falls onto a metallic surface, electrons are emitted from the surface of the metal with the kinetic energy that increases as the frequency of the light is increased. If, however, the frequency of the light incident upon the metal surface has a frequency less than the threshold frequency, then no electrons will be emitted, no matter how bright or intense the light.
So there's just two simple things argued here. There's one where you're sitting there ionizing the atoms. That is, the atoms will release an electron, and the electron is still there. It's on the surface, didn't go anywhere. And then there's releasing an electron with so much energy that it actually leaves the atomic surface. So that's the distinction. But even when it leaves, it wants to go back. Okay, so even when it goes some distance, it's still going to tend to go back to the material substance because there's still a bunch of protons in the material substance that are attracting it, especially from a distance. The further away the electron gets from the other electrons, the more it sees the protons, so to speak. The more the balance switches from electron heavy to proton heavy from its perspective. The smaller the electron gets, as you move away from it. Well, I mean, it's this argument of, something's behind something else, but the something else is bigger. So when you're close, you can block the thing behind, right, completely. But if I move you further away, then that blocking stops, and you now see the thing behind.
This observation could not be explained by the wave theory, which predicted that at low frequencies, electrons should still be emitted. The photoelectron...
So the theory is just under, it's like they're trying to make it too simple. So you could make a wave theory work, or you can make a particle theory work if you deal with the fact that the idea of what's causing the event, that is an electron to leave the atom, what's causing it. So if I make them more complicated, then I can make either one work. So, but yeah, so I mean, again, it's not very good science to pretend they had enough of a model to be able to model either one accurately.
The electric effect was explained by Einstein in 1905 by simply assuming that light is composed of tiny particles called photons, each with energy hf, where f is the frequency of the light, and h...
So this would be correct if they understood that the photon isn't that. The photon contains these little HFs, these quanta. So a photon is a composite object. It has more than one piece to it. So just like an atom isn't a particle, a photon isn't a particle. A photon is a collection of discrete bits of energy at a frequency. I mean, that solves it. I think that will be found to be the correct way to understand a photon. It's not a particle. It is made of little particles in an arrangement.
Which is Planck's constant. As the frequency of the light source increases, so too does the energy of each individual photon. When a photon...
So again, the individual photon, again, the photon's just a pattern in the space. It's just a pattern of on, off. Thing, no thing, no thing, no thing. And the polarization is telling you that it's parallel, but it takes up space. So they're dots in space, like an envelope. You could just put a dot from corner to corner, dot, 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 dot. And if you have the right frequency between them, period between them, then you have a photon.
Count as an electron in the metal, the electron absorbs the energy of the photon. And if this energy is greater than the binding energy holding the electron to the surface, phi, the electron is liberated and leaves the surface, with any excess energy providing the kinetic energy of the electron.
Right, so there's leaving the atom, okay, that's creating charge, and then there's leaving the surface, okay, because you have even more speed. And you have more speed because the frequency means that you're hitting the object with the same force going the same speed, but you're hitting it more often in a shorter amount of time, which means there's less chance the electron has any chance of moving back. So you're always adding the energy. So you add the energy more efficiently the faster. The higher the frequency, the more efficiently you add energy to the electron. So the electron gets going faster because you're adding the energy with less friction, so to speak. To use a different, a word that's not, it's probably not legal to call that friction, but the point is any waste. So you're losing waste by doing it fast.
This simple yet powerful explanation of Einstein's would not only win him the Nobel Prize, but provide the most compelling evidence yet for the particle nature of light. However, it would still take a further 17 years until Arthur Compton's explanation of X-ray scattering using the photon model of light finally convinced the physics community that the particle model needed to be taken very seriously.
So again, that's just more speculation about what people were thinking and who thought what and all that crap. Because they obviously didn't ever take it very seriously. Frankly. But since Huygens, I don't think they've taken particle theory seriously. Because if you took it seriously, you could understand, what's a frequency? The difference here is just the difference between you sitting there saying, okay, I'm looking at the ocean and I see waves. Do I count each wave bump as a photon? Do I say that each bump is just a photon? One bump. Okay, so that's a photon. Or do I recognize that to have a frequency, for me to know what the frequency is even, I have to wait for the timed event. I have to get hit by the wave, and then I wait a certain amount of time, I get hit by another wave, and then I wait a certain amount of time, I get hit by another wave. So if they just understood that, a photon would be a number of those waves collected, and that would be a photon. So it's not that elaborate a difference in way of viewing things. So they always draw the light as multiple wave cycles, and they call it a photon. Like they always draw a photon as many wave cycles. But their math and their theory is basically saying it's only one. It's only this. That's a photon. From their perspective, how they're mathematically viewing it. They're not viewing it as a sequence of events that take a period of time to happen, that photons are created over a period of time, and they're received over a period of time. They're not instantaneous events. So I'm just saying it's, whatever. I don't think they ever thought about that. I never thought about the length of a photon. How many waves are in the photon? And it seems like such an obvious thing to figure out first. It's like one of the first things you have to figure out. Does one wave do it, or do I need more than one wave to hit?
Yet despite the success of the photon model, it was still necessary to adopt the wave theory to account for the interference and diffraction phenomena of light.
So again, that's not true just because they could have understood jamming by now. Once we're getting into the early 1900s, they could figure out signal jamming. Okay, so I just take radio and I put it out of phase, two signals out of phase, and I can't make a receiver that can detect it unless I make a directional antenna. So if I use a regular antenna and I send two out of phase signals at the same amplitude, I'm screwed. I'm not going to be able to detect either one.
And no way whatsoever of reconciling the wave theory with the existence of light particles could be visualized. Physicists at the time were only half joking when they complained about having to teach wave theory of light on Mondays, Wednesdays and Fridays, and the particle theory on Tuesdays, Thursdays and Saturdays.
Right, so it should have been a big giveaway that they haven't done their job yet, so they shouldn't be telling people what is. They should just explain the experiments and why they leave a gap. And if they explain the experiments honestly, that is, as long as they sit there and quit lying about things like the Young geometry works, it gets right answers when it doesn't get right answers, and they knew it. I mean, they could have known it. If they actually did the experiment and actually analyzed it, they'd say, oh, it doesn't really get the right answer. Two waves doesn't really get the right answer, so there must be more to this. And they already did that. I mean, again, the guy who figured out the four source math, he's one of those people that lived back then. So he'd already figured it out, that this isn't about two waves.
Days. What was needed was a new unified vision of atomic physics.
So there's no unification in this stupid wave-particle duality. So to even say that there's any hope that you have unified anything, you've just sat there and accepted a silly notion that when we decide it's a particle, we use particle theory, and when we decide it's a wave, it's a wave. I mean, it's a silly breaking of reality. I just changed reality to suit my experiment. That's the definition of pseudoscience. So anyway, enough for today. So we did get further than usual, 13 minutes worth. Okay, so it's a little better. Anyway, and such and so forth and whatnot. So till the next time. I mean, this is, well, whatever. You can't find an honest challenge. Nobody wants to honestly talk about what the evidence is. They just want to propagandize for their bullshit God ether crap. It's just disgusting. All the scientists are really just religious kooks, apparently. So, till the next time and such, when I'll continue to endeavor to persevere. But for what point? Talking to the wind. But the good news is there's a permanent echo, in that these videos should survive me, and eventually you'll have to concede. Oh yeah, we've wasted a bunch of time ignoring the truth.